3.2 exponent laws. Page 99 in your text. The student will explain the exponent laws for a product of powers be a quotient of powers C power of a power B power of a product E power of a quotient and F when the exponent equals 0. Here, just to summarize before we begin, if the same base we add the exponents we subtract the exponents we multiply the exponents here for the power of a product and power of a quotient we distribute the exponent to the numbers being multiplied and divided. These are just a summary of what these exponent laws are. I'll go on and develop a few frames to explain that. When the exponent is 0, the value is 1. So just in review then, some things from last class and some things from elementary school. A power is a number with a base and exponent, such as 3 to the power of 5. Remember, this is a more efficient way to write three times 3 times 3 5 times. To review some of these terms, sum is the answer to addition. Difference is the answer to subtraction. Product is the result or the answer of multiplication, and a quotient is the answer to division. So we'll go through these exponent laws one at a time. Okay, when we have a product of powers. This is covered on page 101 of your text. If we are multiplying powers with the same base, we can combine them into one power keeping the base the same. I have to get rid of this little object box here. Not sure how I can do that. We'll just leave it there. I'll give you a couple of examples. So for example, 3 to the power of 4 times 3 to the power of 2 equals 3 to the power of 4 and 2 combined to the power of 6. We'll just figure that out. 3 to the power of 4, if you plug that into your calculator or just figure it out quick, you've got 81. times 3 squared is 3 times 3 is 9. 81 times 9 is a value of 729. If you show this with repeat addition, 3 times 3 times 3 times 3 times 3 times 3, this also equals 3 to the power of 6 times, which has the same value as written in the shorter exponent form. So because we can demonstrate that this does not change the answer to the long division, we must be able to do it. So when writing a product of powers, if the base is the same, we can simply add the exponents, keeping the base the same. B, when we have a quotient of powers, this is covered on page 102 of the text. If dividing powers with the same base, we can simply subtract the exponents. Important to leave for leaving the base the same. We can write the base as a single power. For example, 10 to the power of 5 divided by 10 to the power of 2. These two powers have the same base, so we should be able to just subtract the exponents. And we end up with 10 to the power of 3, which equals, has a value of 1,000. If we wrote this out showing long division, we should get the same answer. That's 10 to the power of 5 divided by 10 to the power of 10. If you work these out, these will cancel each of this, and you're left with 3 10s, 10 times 10 times 10, which also equals 1,000. So once again, the exponent laws save us a lot of time and a lot of writing, and then it'll save us with making errors too. See, if we raise a power to an exponent, and this is on page 102 to 103 in our text. We call this power of power. At the beginning of the chapter, it uses that language. So if we have 4 squared, we're going to cube that. That's going to equal 4 squared times 4 squared times 4 squared, which would be 4 times 4 times 4 times 4 times 4 times 4. This is going to be 4 squared 3 times, which equals 4 squared times 3, which equals 4 to the power of 6. And that's what we get when we add up these in long division. So once again, when we have a power to a power, we simply multiply the exponents, and we will end up with the same answer. If you show this, the value of this is 4,096. And if you did these 4s multiplied together, you would also end up with 4,096 this way. So we're good to go. The exponent laws continue to help us shorten it up, still getting the same answer. D, when we raise a product or raise products to an exponent. And this is also on page 102 to 103. For example, if we have 2 times -3, here we have a product, and if we were to raise that to an exponent, if we were to cube this, it would equal 2 times -3, 2 times -3, 2 times -3, multiplied times itself 3 times. Because it's to the power of 3, our product has been raised to the power of 3. We could write this, kind of just get rid of the brackets because they're all multiples. It's all being multiplied. We can get rid of the brackets then, and something that could look like this times like this. Or could read this as 2 cubed times negative 3 cubed. And if we do the math on this, we end up with 8 times negative 27, which equals negative 216. So we could have right away at the beginning, if we had 2 times negative 3 to the power of 3, we could have just distributed this cubed over this term and over this term. And we would have ended with, or arrived right quickly with 2 cubed times negative 3 cubed, which gives us the same answer as that. So when you have a product raised to an exponent, we can distribute the exponent over the two numbers that are being multiplied, and we won't change our answer. E, another exponent law, when we raise a quotient to an exponent. We raise a quotient. Remember that's a division problem or division answer. When we raise a quotient to an exponent, and this is also page 102 to 103, this is covered. We call this a power of a quotient. Before we begin, I want you to realize something about a division that a lot of people don't recognize at grade 9. If you realize that 3 divided by 4 could also be written as 3 divided by 4. 3 over 4 means the same as 3 divided by 4. And that is also written as, could be written as 3 times the reciprocal of 4. These all have the same value, just different ways to write it. And as you get stronger in math, you have to be able to represent values in different ways without changing the value of what you're using. So all of these are called quotients. So if we take a quotient and we raise it to a power or to an exponent, and we do, say, the 3/4, and we raise that to the third power, that's going to equal 3 times 3 times 3, just a dot between also means multiplied, divided by 4 times 4 times 4, which equals 27 over 64. Or we could simply take our quotient that's raised to a power and distribute this power over the two numbers being divided, and you end up with 3 cubed divided by 4 cubed, which is the same value, which equals 27 over 64. So these are the same, and we like that. I'd encourage you to refer to page 103 in your text for a good summary of some of these exponent laws. In the margin of the text, they say these things in a nice, tight fashion. What if the exponent is 0? Well, we're going to use a pattern to demonstrate this. We'll use a pattern to solve this. What is it when an exponent is 0? Well, have a look at this. If you look at 3 to the power of 4, 3 to the power of 3, 3 to the power of 2, 3 to the power of 1, and then 3 to the power of 0. What are we looking at here? Well, 3 to the power of 4 is 81. 3 to the power of 3 is 27. 3 squared is 9. 3 to the power of 1 is itself is 3. And 3 to the power of 0 is what? Well, if we look at this, to get from 81 to 27, we take 1 3 away. We divide by 3, and it's just 3 cubed. Well, to get from 27 to 9, we divide by 3 again. And from 9 to 3, we divide by 3 again. So to get from here, to get rid of that other 3, we must divide by 3 again. Well, 3 divided by 3 gives us 1. So we can summarize then. Okay, so in summary, here, any number to the power of 1 is equal to itself. And any number to the power of 0 is equal to 1. So that kind of summarizes up a whole bunch of the different exponent laws and should keep you from making mistakes. So here's the assignment for 3.2. The 3.2 assignment. This is on page 105 to 107 in your text. And I'd like you to complete this. This is due November 25th. So to get a C, you kind of have to show the lowest level of knowledge. You should be able to complete questions 5 to 19. And many of them have an A, B, and C. You can skip the B, just do A and C wherever it's appropriate. And remember, don't just do the questions and get an answer. Do it to learn the exponent law skills. You can do that. We'll get you we'll let you test and show that knowledge to get a C. To get a B, we're going to require you to apply some of those skills. So to get a B, you must do the assignment, you must complete questions 5 to 23, but I want you to do all the questions, don't skip any. And here, again, don't just do them to get an answer, but make sure you're doing them to learn the skills and applications of those skills in those questions. And to get an A, I want you to complete questions 1 through 26. That includes those first couple that challenge you to explain your answers in words. And I would like you to do all the questions. And here again, I would like you to do this to learn the skills applications and extensions of the exponent laws. You can do that for tomorrow, November 25th. Then we will be ready for you to go over any questions that you might have, and we'll have a quiz ready for you to show your learning.